Welcome back. Last week we talked about forces, and we talked about how loads are weights or items or things that impart forces on objects. And we talked about how stresses are the kind of internal forces that structural members see internally that resist forces that act on them. And we talked about a couple of different kinds of stresses, axial and tangential. And we talked about the notion of equilibrium and how that's kind of our gold standard, right? All of our structures, we don't want them to move, so that we want them to be in static equilibrium. And those concepts help us to understand how forces interact within a structure so that we can build them correctly so they don't fall down. Today we're going to talk about one of the most common pre-engineered construction techniques in stage technology, and that is the 2x4 framed platform. We're going to talk about how they work structurally so we can understand how we're supposed to assemble them and why they are assembled the way they're assembled. And we're going to keep coming back to that concept of going to ground, how the forces need to be transferred from one structural element to another all the way down to the earth that doesn't move so that we stay in static equilibrium. So when we think about a 2x4 framed platform, which is sort of our standard, typical, old school scenic floor construction technique, there are really three structural components. There's the lid or the cover, which for our purposes we'll consider as a beam structurally. There are the 2x4 toggles that run across the grain that are 4 feet long. We're going to call those joists later on. And then there are the 8-foot long members that run the length of the grain of the plywood sheet. So those are the three structural components of a 2x4 framed platform. When we look at that and those components, how do the forces of somebody standing on it get from the person down to the ground? How does the 2x4 framed platform transfer those forces around? Well, it should be obvious, maybe it's not, but it seems obvious to me that when we look down at that platform, the first thing that's carrying the load is that plywood cover. It is the topmost structural member. And as we talked about last time, we're going to think about sort of a person being on it. But we're going to kind of expand that to the idea of a uniformly distributed load across the whole thing. That is how these kinds of structures are rated in terms of a loading capacity over its whole area. And so the plywood then is carrying that full load across its whole area. What then is carrying the plywood? Well, pre-engineered construction techniques tell us that it's the 4-foot toggles that act as joists carrying the plywood. They run perpendicular to the grain, and they actually carry the plywood itself. And it's sort of, from a structural engineering standpoint, the long members don't carry the plywood at all. So if the plywood carries a load and the joists or the toggles carry the plywood, what carries the joists? Well, that would be what the 8-foot members are doing. We're going to call those girders, but those long 8-foot members are what actually carry the 2x4 4-foot members, which carry the plywood lid, which carries the load. And eventually, we'll talk about how all of that gets transferred to some kind of a support, a leg, or some other structural element that carries the girders. All right, so that's great. Rich says that the plywood is carried by the toggles. Who says? How does he come up with that? So the first place we're going to look here in the United States is to APA, the Engineered Wood Association. APA is American Plywood Association. They like to go by the longer title of the Engineered Wood Association. This trade group defines grades of plywood. They define construction methods for plywood and other specifications of engineered materials, so ply lams and engineered joists and that sort of thing. But plywood is kind of their biggest thing. And this trade group provides construction guidance for the use of plywood panels. And that document is called the Panel Design Specification. You can download that for free from the APA website. There's a link on the Brightspace page. If you search the publications page for the panel design specification, or document ID D as in dog 510. You can find this very long document that talks about how we're supposed to use plywood based on how it's been constructed. So that is where we find these pre-engineered construction guidance techniques. The panel design specification tells us a whole lot about plywood. And for our purposes, it kind of breaks plywood up into two groups. First are rated panels, and you'll see these stamped as sturdy floor or rated sheathing. These panels, when used as flooring, they can also be used for walls or for roofs, but when used as flooring, must be supported by joists running across the grain at least 24 inches apart on center. Just tells us that right off the bat. If we're going to use them, that's how we use them, and they will support a load equal to what we would normally see on a residential floor, or a load capacity of at least 50 pounds per square foot. The other group of plywood panels that we might talk about are visually graded veneer panels. And this is what I grew up with. This is what I'm most familiar with, the so-called AB or CD style of plywood. Those letters refer to the niceness of the face grains, right? For those kinds of plywood sheets, we don't get any sort of information about how far apart supports must be, but they provide calculations so that we could determine the appropriate size of panel, the appropriate thickness of panel, the right species and grade for a given loading condition. Those can be a little tedious to work through if you're not familiar with them, and that's not the purpose of today, to learn how to do that. So we're going to not talk about that in detail. However, we can look at a CD sheet of plywood, assuming the weakest species group that we could have them constructed under, or constructed with. At a 3/4 inch thickness, will support a load of at least 95 pounds per square foot, provided that the supports are running across the grain at least 24 inches apart on center. So whether we're using sturdy floor or rated sheathing, or sort of the ugliest, weakest plywood that we could find, a kind of CD weak species, if those panels are 3/4 of an inch thick, we're going to want always to have toggles or joists running perpendicular to the grain, 24 inches apart, at most 24 inches apart on center. And we know in both of those cases then that we will support at least 50 pounds per square foot, closer to like 100 pounds per square foot. And that's fantastic, because we now can dispense with thinking any more about plywood and just go, any kind of plywood sheet that we get that's going to be better than the weakest we can find at 3/4 of an inch thick is going to be more than enough to satisfy our loading condition of 50 pounds per square foot. However, that's only true if we follow the pre-engineered construction guidelines, meaning it must be supported by structural members that run across the grain, and it must be supported every 24 inches or less. And it must be fastened down securely. The panel design specification provides information about the pull-out strength of fasteners, but honestly, this really applies to when loads will want to force the screws out. Think about plywood on a wall that might see a wind load. Typically, we don't have a lot of things pushing upward on the plywood that we have to worry about a pull-out load, so basically any fasteners that we might typically use are probably going to be sufficient. And we could add glue that might help with squeaking, but probably isn't necessary for the structural capacity of the plywood to carry the load that we're talking about here. Okay, so that's the topmost layer. We've dispensed with thinking about plywood. The plywood, we said, it has to be carried by 2x4 or some kind of structural member that runs across the grain every 24 inches or less. So how do we know what kind of a load those can carry and how big they must be? So there's some things we need to know. We typically call them toggles or joists. They are 48 inches across, and we're going to call that the span, because there's nothing going to support them across that 48 inches, right? They're just going to be attached to the 8-foot members, and so that's the span they're going to have, is 48 inches nominally, and they're going to be spaced every 24 inches. Well, what load are those going to have to carry, right? Let's assume a 50-pound per square foot load uniformly distributed over the whole platform, and that is what we would want to see for a loading capacity for a stage platform. Each one of those joists carries some portion of that total load. We call that portion the tributary area. Each joist will carry an area that stretches the length of the joist and from half the distance to the joists on either side. Better with a picture. Let's draw a picture. We imagine a top view of the frame of a 2x4 framed platform. This is obviously not to scale. 8-foot members and the 4-foot joists, right? We know that these are spaced 2 feet apart, and these are spaced 2 feet apart, right? This joist here is going to carry this much of the plywood load from halfway between these two to halfway between these two. That distance is going to be 2 feet. So on a 2x4 framed platform, each of these interior joists is going to carry an area of 2 feet by 4 feet. Now these external joists on either end are going to carry half of that, right? 1 foot by 4 feet, or 4 square feet. Does that make sense? Hope so. So in this 2x4 frame platform, these joists in the interior are going to carry the largest load. So let's just think about those. If we build to that capacity, then we're going to be fine here if we use the same material, right? So this is going to carry a tributary area of 2 feet by 4 feet, or 8 square feet. And if the uniform load is 50 pounds per square foot, we can just multiply 50 times 8 to get the total weight that this joist is going to carry. So 80 times 50, or sorry, 8 times 50 is 400 pounds. That's the load this, and this joist is going to carry, and this joist are going to carry half of that, or 200 pounds. Before, when we were talking about the lids, the plywood, we referred to the panel design specification generated by the Engineered Wood Association, the APA. For sawn lumber, like 2x4, we're going to talk about, or refer to a document called the National Design Specification for Wood Construction, generated by the American Forest and Paper Association, the American Wood Council. I love these long names. A rule of thumb for number 2 grade 2x4 lumber of basically any species. At these kinds of loads, around about 400 pounds total, about 100 pounds per linear foot, we need, for every 1 foot of span, 1 inch of nominal depth. So, for a load of approximately 100 pounds per linear foot along this length, or that is 400 pounds, right? For a number 2, any species of 2x4 lumber, we need, for every 1 foot of span, 1 inch of depth. Well, the span of that joist is 4 feet, and that means we need about 4 inches of depth, or a 2x4. Pretty simple. That's the rule of thumb. That's how we know it works from the American Forest and Paper Association. Just like the panel design specification, the NDS, the National Design Supplement or Specification, provides calculations for determining whether a specific species, grade, and size of sawn lumber will satisfy specific loading requirements. Again, we don't want to do those calculations for this course, but know that they exist, and that's kind of where these rules of thumb come from. I did a quick look at a 4-foot span using a number 2 hemlock fir 2x4, which is one of the weakest species for a bending member like this. On edge, just barely supports a 400-pound load. It's like 401 pounds or something like that, distributed along its whole length. So, by both of these approaches, we can confirm that plywood resting on joists that are 4 foot long, supported on either end, of number 2, any species of 2x4, sufficient capacity to carry the load. That's why a 2x4 framed platform works. That's why it exists the way it exists, because 2x4 is the smallest lumber size we can get away with using to support what would be a 50-pound per square foot load, which is what we would want to see on stage. Okay, sorry, let me just say that one more time, because I think I said it kind of fast. we can assume a number 2 grade 2x4 of most any species used as a joist in this kind of a situation will suffice to support a 50 pound per square foot load, provided that the structural members run across the grain, they're supported, the members themselves are no more than 2 feet, 24 inches apart, and that they are secured to whatever is carrying them, which is kind of the next question. What is carrying them? Well, if the plywood is being carried by these, then these joists are going to be carried by these 8-foot members. We're going to call those girders. Girders carry joists, right? So if the plywood is carried by these joists are in turn carried by these girders on either side. Our rule of thumb from earlier still holds at these kinds of loads, and if we did some math, we'd see that this is going to be approximately equivalent to 100 pounds per linear foot. We need 1 foot for every 1 foot of span, we need 1 inch of depth. The span of a girder on a 4x8 platform is 8 feet. So for this span, we'd need a 2x8. That doesn't make any sense. What's going on here? We have to ask, what carries the girder? If we assume that there are legs in all 4 corners, then there's 1 leg on each corner supporting, or each edge supporting that 8-foot girder. That's an 8-foot span. We know, though, from our rule of thumb, that 2x4s carrying these loads can't span more than 4 feet. That means for a 2x4 framed platform, we need at least 1 more leg smack here in the middle of each long member on each side. Each girder must be carried by 3 supports if we use a number 2 grade of any species 2x4 as the long framing member, 1 at each end and 1 at the center. We should talk a little bit before we wrap this up about fasteners. We haven't really talked about that. We mentioned a little bit that we could use any kind of screw, we don't need glue for the lid, but we haven't talked about where these meet these, where the joists meet the girders. If the girder carries those joists, how they're secured to each other matters, because we got to figure out how to transfer those forces across. What does that joint look like? So a typical scenic practice for well or ill, and this will undoubtedly get lots of comments, is to use sheetrock and drywall screws, and to drive those sheetrock screws through the 8-foot member into the end grain of the 4-foot members. So we've got our girder here and our joist here, and we're going to drive a screw through the girder into the joist. It's common practice. We've all done it. I've done it probably a million times. There's some problems with this structurally. First, this puts a pretty significant shear load on the sheetrock screws, right? So remember we talked about shear. If the joists are carried by the girder, the joists want to sink and the girder doesn't, which means those drywall screws are now in shear, which is bad. They're not strong that way. This is reduced somewhat because the plywood lid rests across that joint, and that carries some of the load. But then that now means we're putting the plywood in shear along that 8-foot member, and we haven't really analyzed the plywood for its ability to resist that. So that's worth knowing. So, okay practice, because we know empirically that it usually works out just fine, is to use sheetrock screws for short-term installations of these 2x4 framed platforms, provided we kind of inspect them regularly for if things are starting to pull apart or break, or if screws are starting to break. Good practice, better practice, would be to use wood screws. Wood screws are designed to resist shear far better than drywall screws. And so we're increasing the ability of that joint to hold against the shear load that's happening. Best practice, no one ever does this, but probably we should, is to use joist hangers. That is the reason joist hangers exist in housing construction, is they provide a method for hanging the joist off the girder so that we don't have any shear loads, we just have more tensile or compressive loads, if that makes sense, which the joist hanger is designed to resist well. That would be best practice. I'm betting no one's going to go away from this starting to use joist hangers in their 2x4 framed platforms, and that's okay because we're going to use them for shorter lengths of time. They're not in use 100% of the time, all the time, and we have opportunities to inspect them in between uses. Okay, we covered a lot of material. So just to sum up, loads on a 2x4 frame platform. There's 3 basic structural components. There's the plywood lid, there are the 2x4 joists that run across the grain, and then there's the 2x4 girders that run along the grain. The plywood is rated at 3/4 inch plywood of just about any species, CD grade, which is kind of the lowest, weakest grade. Any of those would be rated for at least 95 pounds per square foot load, provided that those toggles are 24 inches on center, which is why we build it that way, right? The toggles, 2x4 toggles, number 2 grade, even the weakest species, when they span 4 feet, can hold a load of about 100 pounds per linear foot, which is what we would see in a 2x4 frame platform at its greatest capacity that we would want, as long as they're supported at either end of 4 feet, more than sufficient. That's why a 2x4 framed platform is built the way it is. Those joists are carried then by the 8-foot members. The same rules of thumb apply. If we only want to use a 2x4, we can't span that full 8 feet. We need to have supports at a minimum of 4 feet, a maximum of 4 feet away. So the corners and 1 in the center. All right. Next time we're going to talk about legs and other methods of supporting those girders for a typical 2x4 frame platform kind of installation. Thanks.